So in this video, I'm introducing electromagnetic waves. Electromagnetic waves are anything from gamma rays, X-rays, ultraviolet, the visible spectrum, so all the light that our eyes can see, infrared, microwave, and radio waves. So this is the electromagnetic spectrum here. And as you go from left to right, you're increasing the wavelength of the light. So each wave of the light gets bigger in space as you move to the right. Increasing frequency, so frequency is how rapidly something changes from one extreme to the other. When we were doing a pendulum lab, the frequency is how long it took the pendulum to go from one side to the other and back. Remember the period, that's the period. The frequency is how many times it does this per second. Okay, so frequency is how many times does the light cycle per second, and that increases as you go from right to left. Not on this, but also important, is the energy. So energy also increases the same way frequency does. So energy increasing is from right to left. So gamma rays have much more energy than radio waves. A much smaller, much faster frequency, and a much smaller wavelength. So the concepts here, one is speed of light. So speed of light is a constant across that entire spectrum. All light travels at 3 × 10⁸ meters per second if in vacuum. Now if it's passing through a material like air or glass or water, anything, the speed of light actually slows down in the material. So something like water or glass, it will slow down maybe from 3 to 2 × 10⁸ meters per second. Doesn't sound like much, but it has actually a great effect on what happens to the light when it enters the material. Spectrum, that was the picture on the last page. We just went over that. So wavelength, again, is the distance from one peak to the next. So light is a wave. So one wavelength is this distance. So if this is in meters, so distance. So if this is a distance, you just freeze the light at a moment in time, then that distance is one wavelength. Now frequency is how many times, if I sit in one place and let this light go past me, it's how long does it take, the period is how long does it take to get from a bottom to another bottom if I sit here in time waiting for the light to go past. The frequency is how many times it does that per second, and that's measured in hertz. So that's the time, the period is the time from one peak to the next. That's the period. And then the frequency is 1 over the period. Okay. I'm sorry. Period T. There we go. And the one and only mathematical model, C, that's the speed of light. Equals lambda naught, that is the wavelength in vacuum. So that 0 on the lambda naught, that refers to vacuum, and so no material. And then the F, that's the frequency of the light.